Alright guys, we are looking at Chapter 10, Section 4. We're looking at just the first part of Section 4. We're just going to cover radians in this video. So let's go. What are radians and what is it that I'm looking for you to be able to do? Well, I want you to be able to convert between degree and radian measures of an angle and find the length of an arc. That's what I'm looking for you to be able to do by the end of this lesson. So let's get started. I want to review a little bit of our understanding of circles. There's a term called circumference, and circumference of a circle is just the distance around that figure. It is the formula C for circumference equals 2 pi r, or you could write it pi d. R represents radius and D represents diameter. Now another term, probably less familiar but really important in our lesson today, is arc length. An arc length of a circle is just the distance around the figure, but it's not the whole figure, it's just within the boundary of a central angle. So take for example this circle. The circumference would be all the way around it, whereas arc length would just be this red section here. That is where your central angle, the angle that's going from the center of your circle, where it intercepts your circumference. So we're looking to find S. S is your arc length here. Well, we can do this. Notice that S, your arc length, is just a part of your circle. Here it's not going all the way around. It's not going 360 degrees. It's only going 60 degrees of your circle. So it's really just a portion of your circumference. It's 60 out of 360 of your circumference. That 2 pi 4, that's circumference. R is 4 here. So we can simplify. It would be 8 pi. That's the 2 and the 4 being multiplied. And 60 divided by 360 is really just 1/6. Okay, and we can go a little bit further in our simplification. Both of those are even numbers, 8 and 6. So we can divide them by 2, and you'll end up with 4 pi over 3. Okay, well that was cool. That would be 4 pi over 3 is the distance along the arc there, but just within that red region. So what is radian measure? That's what this lesson is all about. What does it really mean? Radian measure, it's defined as the ratio of the arc length, which is S, to the radius, which is R. And the formula looks like this. Radian measure, theta, is S, that arc length, divided by R. And guys, when we're working with radians, it's just a different unit than degrees. So you know, like you've worked with converting between meters and yards. You've worked with converting between miles and kilometers. You've gone through that process of doing the conversions, and that's really what we're working with here. We're just working with giving a measure in a different unit. So let's try and find what theta would be in radians. We would just take our arc length, which is 4 pi over 3, and divide it by 4. Now we can't really, this fraction divided by something, what we do in that scenario is we, instead of dividing, we multiply by the reciprocal of that denominator. So take 4's reciprocal, it's 1/4, and simplified it would be pi over 3. Pi over 3 is the radian measure of that angle theta, and that in degrees was 60. So we're seeing here, okay, pi over 3 radians is the same thing as 60 degrees. And you might be thinking, why do we have to work in radians? hold on, hang in there. I'm going to show you that they really are going to be very beneficial for us in the very near future. Just you've got to trust me for a little bit. Okay. Let's talk about converting between them. I'm going to show you this figure again here. And we've got a little piece of our pi cut out. Pi over 3. Now I want to continue to divide up my circle into these little sections, okay? This is a 60-degree angle cut out, but you could continue to cut that out, this pi over 3, 60 degrees. So there's another pi over 3, and there's another pi over 3. Now look here. We have gone halfway around our circle, right? Think about it. What is half of a circle? Hold that in your mind. Pi over 3 plus pi over 3 plus pi over 3 would be how many radians? Let's think about this. 1/3 and 1/3 and 1/3 is 3/3. 3/3 is really just 1. We're looking at pi. Pi is equivalent to 180 when you're working in a radian measure. Pi radians is 180 degrees. And that is going to be one of our conversion factors. Pi radians over 180 is equivalent to 1. Now let's keep going here. Let's continue to divide up our circle. So that top half was pi, which means our bottom half is also pi. If you took those 3 pieces there and added them up, that would be pi. So what is a whole revolution? 2 pi radians. 2 pi radians is the same thing as 360 degrees, and that is going to give us another conversion factor. So you could use either one of those. They both are equivalent to 1. And I want to keep working just in radians for a bit more here and understanding where they would be positioned. You guys have gotten really good at being able to sketch an angle in the coordinate plane in degrees. Now let's make sure we can do it in radians. So where would 2 pi over 3 fall? Where would it terminate? Well, let's think about it here. We know that this represents pi radians, and over here is 2 pi. But what about that 90-degree mark? What is that in radians? Well, it's halfway to pi. Half of pi. Pi divided by 2. And that 270, that's really like 3 of those 90s put together, right? 1, 2, 3 of those pi over 2s, 3 pi over 2s. So 3 pi over 2 is the same thing as 270. Pi is the same thing as 180. Pi over 2 is 90. And 2 pi is a full revolution, is 360. Okay, now we're still just trying to figure out where would the terminal side lie. Well, think about it here. 2/3 is greater than 1/2, right? But it's less than 1. So where does that fall here? Well, 1/2 is that 90-degree mark, and 1 is pi, so it must fall in between there. It's about 2/3 the way to your 1 mark, to pi. So it would be in quadrant 2. Let's do another. Let's say that we had 7 pi over 5. Okay, well, where is that going to be? 7 over 5. 7/5 is greater than 1. It's actually, 7/5 is 1.4. I'm just really smart. That's why I knew that. If you didn't know that, sorry. 7/5 is 1.4, which means it's less than 3/2 because 3/2 is 1.5. So it's going to fall in this third quadrant. It's, you know, guys, we're what we're doing is we're just kind of dividing our circle into those divisions, into fifths. So that would be more than a half of your circle if you're talking about 7/5. A full circle would be 10/5. Let's keep going here. What if you had negative pi over 4? Now, what is that negative going to mean for us? Where instead of measuring up and over, we're going to go down. We're going to go down. Well, how much is pi over 4? Think about this here. 1/4 is really half of 1/2. Now, what did our 1/2 represent in radians? It was our 90. So half of that 90 is going to be 45. So I have gone down 45 degrees. I have gone down pi over 4 radians, which means we are in quadrant 4. All right, so that is all for just kind of like sketching those terminal rays based on your angle. Now let's go through the process of converting. So here we have a radian measure, and we're going to convert it to degrees. Now, pi over 2, we already went through this. We know the answer we should get. Let's see how it's done mathematically. What we're going to do is use that conversion factor. And we want to cancel out the radians, so we're going to put radians in the denominator. It's just flipped from what you saw on that first page there at the bottom, right? We've flipped it so that our radians, our pi's can cancel out, and our answer is going to be in degrees. Now let's simplify here. 2 and 180, that can really simplify to 1 and 90. So we're looking at 90 degrees. Pi over 2 radians is 90 degrees. What about negative 5 pi over 6? Well, again, we have a radian measure, so we're going to try and cancel out the radians and give your answer in degrees using that unit conversion. This will mean that our pi's cancel out. And let's see here, 6 and 180, you can simplify that. It can go in there once and 30 times. So we're looking at negative 5 times 30, that's negative 150 degrees. Okay, here's another one, and I want you all to pause the video here and work through this one on your own. Pause the video and then we'll go through it together. Okay, it would be 5 pi over 3 times, and you want your radians in the denominator so that you can cancel the pi's out. Simplify on your diagonal here. 3 can go into 3 once, and 3 can go into 180 60 times. So in the denominator, well, you won't have anything, it's a 1. And in the numerator, 5 times 60, that is 300 degrees. All right, we have one more, and I again want you to pause and try this on your own. All right, let's try this together. Let's see if you have it correct. It would be 3 pi over 4 times our conversion factor, canceling out the radians and simplifying on the diagonal. 4 can go into 4 once and into 180 45 times. 3 times 45, that's going to give us 135 degrees. All right, so that was converting 2 degrees given that you were in radian measure. Now let's do the reverse. Let's go from degrees to radians. So this is 45 degrees, and I want to cancel out the degrees. So I'm going to use degrees in now the denominator so that radians will be in our numerator as our final unit. I can simplify here, and I know 5 goes into both of those. That was just the easiest I could do, and I'm trying not to use a calculator. So 5 goes into 45. I'm sorry, 9 goes into both of those. 9 goes into 45 and gives you 5, and 9 goes into 180 20 times. Okay, but I know I can go a little further because 5 and 20 have something in common. I can again divide each of those now by 5, and it will be 1 and 4. So what do we have on top? We have pi, and in the bottom we have 4. And we actually kind of went through this earlier. 45 degrees, half of 90, is half of pi over 2, which is pi over 4. So fantastic. Let's keep going. Let's try to convert 300 degrees to radians. Again, we're going to set this up and try and use our unit conversions, making sure that we're canceling out degrees, and radians is in the numerator as our final unit. Okay, I know that both those numbers can be divided by 10. So that just kind of makes it a little bit easier to look at now. I'm looking at 30 and 18. What goes into both of those? Well, let's see. Oh, 6 can go into both those, right? And so that would be 18 divided by 6 is 3, and 30 divided by 6 is 5. So in the numerator we have 5 pi, and in the denominator just 3. So 300 degrees is the same thing as 5 pi over 3 radians. All right, so here we go. We're working with a negative rotation here, and I want you guys to try to do this one on your own. So pause the video and we'll check it together in just a moment. All right, so we set up our unit conversion, making sure that degrees will cancel out, and I can divide each of those by 10 so that I'm working with something a little smaller here. And again, those are both able to simplify because 6 can go into both of those, which gives us in the numerator a negative 4 and in the denominator a 3. So we're looking at negative 4 pi over 3 radians. One more. This is the last problem, guys. Again, challenge yourself. Come on, I want you guys to do it. Pause the video, make it happen. All right, let's see, what do we have here? 160 degrees. Let's make sure we set it up so that degrees cancel out. Both those end in 0, so they're divisible by 10. 16 and 18. Can that be simplified? What is the largest number that can divide into both of those? Let's see. Oh, it's just 2. So that would be 8 and 9. So we're looking at 8 pi over 9. All right, that's it. That is what I wanted to share with you guys about radians. And you should be able to do both those objectives now. So if you had any questions, make sure that you write them in the margin so that we can discuss them together. I will see you guys soon. Thanks.